Okay, before anything, just wanted to mention on the graphs of sine and cosine functions, you are going to need two of the graph paper things for trig graph paper because we're going to have to use this. So that's the first thing. The next thing, just as a reminder, if you're graphing the sine, cosine, and tangent functions, make sure you're in the right mode, because if I were in degree mode and I put sine x, it would look like that, which is wrong. Yeah, you have to be in radian mode. So if I click radian, then it changed it to how it's supposed to be. So make sure you're aware of that. Remember, you can hit the trig button and then see all of your functions. Okay, so now let's go to the notes. Your objective is to be able to graph functions of the form a sine wx, and that w is really omega, and then the a cosine wx. So in other words, we're going to have a number in front of sine that's not just the default, that's 1. And we're going to have a number in front of x, which is not just the default, which is 1. So that's how you can think about it. Now, depending on what pre-cal textbook you're using, sometimes they use the w, sometimes they use the b instead. So I just want you to get used to it. In some textbooks, the one when you have all 4 transformations would not only have the A and the B, like right there, it also have a C and it also have a D. In ours, we'll get to this other part later, but one of them is the phi. So we'll talk about that when the time comes. Number 2, determine the amplitude and period, and be able to find your equation for the sinusoidal graph. That just means a sine or cosine graph. That's what sinusoidal means. It's a sine or cosine graph. So while we're studying this, the graphs are sometimes used in school spirit and Christmas decorations. Y'all may or may not already know this, cheerleaders, but like, let's just say your eyes, and I know I can't draw great, but here we go. What y'all do sometimes in football season is you put a little decoration like that. And so that's like half of a sine graph or half of a cosine graph. Okay? Yeah, without even knowing. So, right. Right. So other applications and word problems are about AC circuits and generators, bridge clearance, and biorhythms. So number 1, since we want to graph the traditional trig functions in the xy plane, we should use your traditional symbols: x for the independent variable, which is also called the argument, and y for the dependent variable, which is the value at x for each function. For example, y equal f of x, which is sine x. So just remember, like before, independent is x, dependent is y, which is also called the value of x. Okay, number 2, pay close attention to intervals on requested problems. Sometimes it's 0 to 2 pi, including those points. Sometimes it includes the front but not the back. Sometimes it includes from negative pi to pi. And also sometimes they want to show more than one period. So just pay attention to what they want. The default on the trig window is to show 2 periods worth. For example, if I go to Menu, Window, and then trig, which is 8. Think of 0 to 2 pi is one period, and think of negative 2 pi to 0 as another period. So that's the default, and that's how your trig graph paper is, from negative 2 pi to 2 pi. Now, one of the things we're learning about today is about the amplitude. And so, like for example, if you just put a number in front of the sign, like 3, that means you're going to go up 3 and down 3. So that's where it comes from. So even though your total height is 6, our amplitude is 3 because it's from the middle to the top or from the middle to the bottom. So that's the first thing. The other thing is about the W, and that's a little bit more complicated than the amplitude. If you put a 2 here, for example, it's either going to be more wavy or less wavy. So let's find out. So if we double it, it's more wavy, it looks like, because we now have more things here. If I compare it in red to the regular sin x was that, and so when it was sin 2x, it was more wavy. Okay, so let's talk about this just to the side. Sin 2x is more wavy than sin x. Okay, so I'm just going to write that to the side. Okay, so now let's continue. Number 3, the amplitude is the vertical height. Amplitude is the vertical height from the middle of the graph. I'm saying the middle of the graph would be the x-axis. Okay? And is always positive. And the period is the horizontal distance. If you want to label middle of the graph as x-axis, you can. That's optional. That's what we meant. Okay, so the amplitude is the vertical height from the middle. I guess I should technically put sometimes the x-axis. I know I'm getting a little ahead of myself, but we haven't gotten to vertical changes yet. And I just want to cover myself in case you're watching this video later. So the middle of the graph is there. When we do our vertical translation, that's just going to be like +1 or whatever. So now your middle would be here at 1. And so instead of the middle being the x-axis, it's going to be that number. So we'll talk a whole lot more about that later, but that's where the vertical translation comes into play. Okay, so vertical, positive, horizontal, and it's for one complete cycle. If the period is pi thirds, think that it repeats every 60 degrees when it's normally every 360 degrees. Number 4, the period does not show up explicitly on A sin WX. So in other words, you may see a number for A and a number for W, but the W number is not the same as the period. The period uses the letter either capital T or capital P. You have to use the below equation to figure out the period. You either use this one, T equal NP over W, where NP is the normal period, or you use period is the normal period divided by B. So again, depending on whatever textbook you're using, if you're using the one we have, it's going to use T and W, but if you're using a different one, it may do P and B. So you might want to highlight this part, that the normal period is 2 pi for sine, cosine, cosecant, and secant, and the normal period is pi for tangent and cotangent. We'll get to some problem examples on this for in a few minutes. But that's one of the formulas you need. And it's not n times p. We just call that the normal period. So you're going to do a substitution. You're going to call it 2 pi or you're going to call it pi, depending on what function you're doing. Okay, number 5, your properties of the sine function. The domain is the set of all real numbers. This is kind of like your previous notes. The range consists of numbers from -1 to 1. And that's going to be inclusive. Inclusive. So that means it actually includes that number. So -1 would be a minimum. Bless you. -1 would be a minimum, and +1 would be a maximum. So it actually includes those numbers. C is the sine function is an odd function, meaning that it's symmetric to the origin. So remember what we said before about that. It's going to look like that. And so like this point would correspond to this point. It's symmetric to the origin. The sine is periodic, which has period 2 pi, because it's always 2 pi except for tan and cotan for your normal period. And then as far as the x-intercepts, are -2 pi, -pi, 0, pi, 2 pi, 3 pi, etc. As far as the y-intercept, there's only one because it's a function, and it's a 0 because it goes through the ordered pair 0, 0. So the x-intercept and the y-intercept are 0 because of this point right there. So that's before any sort of translation or shifting left or right. The maximum is at 1, and it occurs at -3 pi halves, pi halves, 5 pi halves, 9 pi halves, etc. And then the minimum value is at -1, and it occurs at -pi halves, 3 pi halves, 7 pi halves, 11 pi halves, etc. So it's not just at every single odd multiple, because it goes max, min, max, min, max, min. Or you can even say min, max, max. So it's just back and forth. Any questions? Okay, so then for the cosine, it's going to be very, very similar. The domain is a set of all reals. The range is from -1 to 1 inclusive, meaning it includes those numbers. On C, cosine is an even function because it's symmetric to the y-axis. So there's a rough sketch of it. At the origin, it starts high at 0, 1, and then it comes down to -1, and then so forth. So this is symmetric, like this way, symmetric to the y-axis. For D, cosine is periodic, which means it repeats, and it has period 2 pi. The x-intercepts are -3 pi halves, -pi halves, positive pi halves, and 3 pi halves, 5 pi halves, etc. The y-intercept is 1 because it goes through the ordered pair 0, 1, like we said. Yeah. Let me pause this. Okay, so the x-intercepts are listed, and the y-intercept is 1 because it goes through 0, 1. For F, the maximum is at 1, just like the sine graph. And these happen at -2 pi, 0, 2 pi, 4 pi, 6 pi, etc. And then the minimum is at -1 and is at -pi, pi, 3 pi, 5 pi, etc. So again, they just alternate. Okay, number 7, because the cosine is the same as the sine if it's shifted right pi halves, the formula is sine equal cosine x minus pi halves. Remember on your translations, if there's a minus sign, that relates to right, and like on this one, the plus sign relates to left. So let's compare these on the graph. So first off, I'm going to take off the 1, and so there's the sine graph. If we just did the cosine graph like this, it's just off a little bit. And so if we go to the side, okay, let's just say we did -1. If we go right 1, that's pretty close, but it's not exact. The exact would be if it's minus pi halves. And that way they coincide. Okay, and let's do the other one also. So if we have the cosine graph, I put cosine x, it starts high right there, and if I just did sine x, it would look like that, and so we have to move it. So I'll do a plus pi halves. You remember the button I'm using is the pi button, which is to the left of the H, and that pops up this menu. Remember, this is the pi and this is the degree symbol. Those are the main things we use. There's also a theta, but I always just use x because it's just easier that way. Because if I'm using f of x, then I need x to be my independent. So x plus pi, whoops, I forgot to put the divide by 2. Divide by 2. Okay, there we go. Okay, so that's how that graph works. For number 9, if w is greater than 0, then the amplitude are given by the amplitude equals the absolute value of A and the period is the t variable, which is 2 pi over w. Remember, amplitude is always positive because it's a distance. So let's just give a quick example. If you have y equal 3 sine x, then the amplitude is 3. It's just the number in front. But if it's y equal negative 2 sine x, your amplitude would be positive 2, not negative 2. Okay. So amplitude is positive because it's a distance. Okay, number 10. When using your formula t equal 2 pi over w, here's just something I picked up on since I've taught pre-cal so long. If w has pi in it, like if it's 2 pi over pi, then the period will not, or won't, because it cancels. So, for example, if w is 3, then it's just 2 pi thirds. But if w is 3 pi, then your pi's cancel, and so your period would be 2 thirds. So your period and your w have opposites on that. One of them has pi, the other won't. Okay, number 11, your steps for graphing it are a sine wx. We want to use our key points. Determine your amplitude and period. Divide it into 4 subintervals the same length. Because you notice it's going to repeat, so you need little pieces that are the same length. So you have amplitude, period, and length. Pay attention to the middle line, and as we said earlier, the default is the x-axis. X-axis. Use the endpoints of the subintervals to determine your 5 key points, so that way you'll know where to curve it. Plot those 5 key points and draw a sinusoidal graph to obtain the graph of the function of one cycle, and then extend it in each direction to make it complete. Okay, so that's the end of the notes. Here's your problem list. I'll pause this while you write that down. Okay, so there's your header with your problem numbers. It's 6.4, page 408, numbers 3 through 8, 10 to 20 even, 21 to 34 all, 36 to 52 every other even. Those are the ones you're going to need graph paper for, and then 60 to 72 even. Okay, so your first ones are vocabulary type problems. And so the very first one says the maximum of sine is, the maximum of sine is 1. That's a y value. Bless you. And that happens at pi halves, which is an x value, in the interval from 0 to 2 pi. So whenever we're talking about maximums and minimums are y values, and then the location would be an x value. Okay, number 4, here's your formula, y equal a sine wx. And in this problem it says it has amplitude that is 3 and period that's 2. So the question says, what are A and W? Okay, so number 4, y equal a sine wx, has amplitude 3 and period 2. What are A and W? Okay, so the amplitude is 3. It's not a trick question on this. It's very simple. It's A equal 3 because of the, AWX. Now, to get the other part, we've got to use our formula, T equals the normal period divided by W. And this is where you're going to substitute. The period is 2, which means T is 2. So I put a 2 there. The normal period is going to be 2 pi, because if it's sine, cosine, cosecant, or secant, then you get 2 pi. And then we have W down here. So then you have to solve for W. So you bring the W over by multiplying, and you divide this. So you get W is 2 pi divided by 2, which is simply pi. So A equal 3, W equal pi. So then your formula is y equal 3 sine pi x. Just over to the side, this is from your notes. Recall you could have used P equal NP divided by B instead. And you could have said y equal A times BX minus C plus D instead of y equal A WX. And I'm not going to fill in this other part, but I believe it's like a minus phi and so forth. So I'm just going to do a dot, dot, dot right there. So, like I said earlier, your textbook uses the T, some textbooks use the P, and the A, B, C, and D. Any questions? Okay, so then our last one is number 5 for today. 3 cosine 6x. And so our amplitude is 3 because it's the number in front. If you're not paying attention, you may just say your period's 6, but it's not. You got to say the period is the normal period, which is 2 pi divided by 6. And then if they're even, you got to reduce that so you get pi thirds. So your period's pi thirds. So again, think of that as, well, let's graph it to be sure. Is it more wavy or less wavy? Let's find out. Three cosine 6x. Yeah, that's a lot more wavy. So remember, if your number is bigger than 1, it's going to be more wavy. And so remember from other lessons we talked about this could be sort of like a heartbeat, or it could be other types of functions, maybe related to sound waves. Okay, the next video starts with number 6. I'm going to stop this video now.